The second question of homework 10 of the probability and the stochastic is collect definition of properties of stochastic process. First is Y-sense stationary process. And the properties is expected value of x of t equals eta, and eta equals constant. So the mean value doesn't change even if how time changes. For example, expected value of x of t plus 1, it also equals eta. And the second is autocorrelation. Autocorrelation only depends on t1 minus t2. It's true. As long as t1 minus t2 does not change, the autocorrelation will not be changed, so time can be shifted randomly. And the second is independent increment process. And the definition is x has independent increments if for t1 to the tn with t1 smaller than t2 and smaller than tn, the increments xt1 and xt2 minus xt1 and to the xtn minus xtn minus 1 are independent. It means x has independent increments. And the Poisson process is a special independent increment process. And the third is Markov process. Let us assume t1 bigger than t2 and larger than tn. Then the probability of x of t1 smaller than x1 given x of t2 equals x2 and to the x of tn equals xn. It equals the probability of x of t1 smaller than x1 given x of t2 equals x2. So the Markov process is a process such that the probability happened in time t1 are related to the event happened in the latest time. And the fourth is strict sense stationary process. For all c and all x1 to the xn and t1 to the tn and n, the CDF of a CDF of x1 to the xn and t1 to the tn equals CDF of x1 to the xn and t1 plus c, t2 plus c to the tn plus c. So the strict sense stationary process is the first order distribution is independent of time t, and the second order distribution like the distribution of any two samples like x of t1 and x of t2, it depends only on tau equals t1 minus t2, t2 minus t1. And the fifth is white noise. White noise is a process such that its value at different times x of ti and x of tj are uncorrelated. So the expected value of n of t1 minus eta of t1 times x of t2 minus eta of t2, it equals 0. So the covariance, it equals q to the t1 times it's called impulse signal, of t1 minus t2. So according to the covariance of the white noise, we get if and only if t1 equals t2, the value of covariance equals q of t1. Otherwise, it equals 0. So that's all. Thank you.